So dear students, today we will be starting our first chapter of science in class 10. Yes? Class 10 first chapter we have, there is force. It's the chapter 1 in force. Check it out here. What we are going to study in this chapter. We have summarized the objectives of these chapters as topics. We will be dealing here with gravitation. What is gravitation? Next is Newton's law of gravitation. Who formulated this law of gravitation? It was Newton. So we will be dealing with this Newton's law of gravitation. We will be deriving some formulas. We will be knowing about gravity. What is gravity? Then we will march to what is acceleration due to gravity. Again, then we will have to go to variation of g on the earth. G denotes acceleration due to gravity. Next is we will be knowing about what is free fall and what is weightlessness. Then finally we will be also recalculating mass and weight. This mass and weight, though we have taken in class 8, class 9, but then we will just recall this what is mass and weight in class 10. So we'll start with the first topic, that is gravitation. See, gravitation. What is this gravitation? So before going to this gravitation, why this gravitation has been important to be discussed or to be learned, we will move to it first. Before gravitation, we will have a small recap. That is what happened before 16th century. Before 16th century, 16औं शताब्दी भन्दा पहिले, people used to think that earth is the center in our solar system. हाम्रो सोलर सिस्टम को सेन्टर भनेको सन नभइकन अर्थ हो भन्ने कुरा 16औं शताब्दी भन्दा पहिलेका मान्छेहरूले त्यो बुझ्थे. And it was given by a scientist. It was Ptolemy. So we say Ptolemy's theory also, and this theory is known as geocentric theory. Geocentric theory. Ptolemy was a scientist who formulated that Earth is in the center of the solar system and rest other masses that we say the moon or that time to बेलामा जुन heavenly bodies हरु planets हरु पत्ता लागेको थियो. त Ptolemy 16औं शताब्दी भन्दा पहिलेका मान्छेहरूले के बुझ्थे भने अर्थ बीचमा छ, earth is here, yes, and moon, sun, etc. revolves around this earth, our planet. हाम्रो planet जुन earth छ त्यसलाई sunले moonले अरु planetsले घुम्छन्. Though we know that this is not true because of the development in the 16th century. 16औं शताब्दीमा there was a fine scientist, there was very important scientist who was Nicolaus Copernicus. Nicolaus Copernicus was the first man to confirm that Earth is not the center of the solar system, rather Earth is one of the components of the solar system in which Sun is the center, and other heavenly bodies that we have the model of the solar system, that is Mercury, Venus, Earth, Mars, yes, Earth, around the Earth ko moon pani huncha, these all etc. जुन हाम्रो अहिले सोलर सिस्टम को मोडल छ, the present day solar system model was given by Nicolaus Copernicus in 16th century only. From then only it was confirmed that, or people came to know that sun is the center of the solar system. Rest all heavenly bodies, जति पनि अरु heavenly bodies हरु छन्, planets हरु छन्, satellites हरु छन् सोलर सिस्टम मा, त्यो सबैले सनलाई परिक्रमा गर्छ. It revolves around the sun. Yes, and this theory is known as heliocentric theory. It was G-O-R-Y. Heliocentric theory. Who propounded this heliocentric theory? It was Nicolaus Copernicus. Before that, we have the Ptolemaic theory, in which every person believed that Earth is the center. Yes, and rest other planets to revolve around the Earth. But after Copernicus, who proved that it is not possible in that way, Sun is there. He has designed his telescope through which he viewed it and he showed it, he proved it, and then the people have come to accept that Sun is the center, and this theory is known as heliocentric theory. So, what we came to know is there are heavenly bodies that revolves around the Sun, and that is a solar system. Yes? From this, there arises a question in the mind of a very veteran scientist who has given lots of theories, lots of laws, that we say Newton's law of gravitation. I have written it here, but we will first move to what is gravitation. This heliocentric theory made Newton to think why these heavenly bodies do revolve around the sun. यो सनको पर्किनमा किन गर्छ? कुनै चीजलाई गोलो 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 यसरी घुमाइराख्यो भनेपछि त्यो त फुत्त भाग्नु पर्ने हो. बट what is there? There is nothing tying up. कुनै चीजले सनले तिनीहरुलाई घेरेर तानेर राखेको हुनु पर्यो, नत्र यत्रो स्पिडमा घुम्ने चीज जुन छ त्यो त फुत्त बनेर it can escape into the स्पेसमा हराइसकेको हुनु पर्छ. त्यो प्लैनेट्सहरु त्यो हराउँदैनन्. सनको गोलो 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 आजीवन कहिलेदेखि हजारौं लाखौं करोडौं वर्षदेखि घुमिरहेको छ. व्हाट इज देयर? हैन, कुनै न कुनै चीज फोर्स त हुनु पर्छ. यस, त्यो फोर्स के होला जसले गर्दाखेरि यिनीहरु एकै ठाउँमा छन्, त्यो सर्कुलर परिक्रमा घुम्छन् र किन? There comes gravitation. So Newton tells this. Newton has told us that there is a force of attraction. There is a force of attraction between any two bodies in the universe. Known as gravitation. This is this. Newton told that there is always a force of attraction between any two bodies in the universe. You can take this duster is here, what we say, wiper, or this marker. If these two are here, these two bodies are also attracting each other. Yes, though we cannot know it, we cannot feel it, we cannot see it. We will discuss this thing in the same chapter later on. But for now, you should understand that this marker is also attracting this wiper, and this wiper is also attracting this marker. This is what we say gravitation. Similarly, more profoundly, the moon also attracts the sun also attracts the moon. In the same way, the sun also attracts the earth also attracts the sun. And this is what we say gravitation. And this gravitation is applicable for everything in the universe. It is not limited for this chalk and, or this is not applicable for sun and moon, sun and earth. It is applicable for everything, hence it is universal. So gravitation came into existence because of that heliocentric theory. Why the planets revolve around the sun? Yes, the answer is there is the force of attraction between any two bodies in the universe. Means everybody attracts each other, therefore this binding force do not let them to escape. Now, if we talk in the same way, we can also say that if these two chalk, this duster and this marker, they are here, why they are not always here? If we leave, they fall down, it's like this. Yes, it happens in this way, but they are not here. So we will know about it, why something gets bind at a fixed place, or they are at the same distance always, revolving at the same distance. This will be given by Newton's law of gravitation, where he talked about, जहाँ उसले के टक गरे भने पछाडिबाट किन बाइन्डिङ हुन्छ हो, किन एक ठाउँमा बस्न सक्छन् किन एक ठाउँमा बसेको हुँदैन जबकि फोर्स अफ एट्र्याक्सन जहिले पनि रहन्छ त्यतिखेर हामी कसरी त्यसको आन्सर दिन्छौं if anything is held together is bound together is made at a certain distance for that you need to apply a reasonable a remarkable force on it if the value of the force if the magnitude of the force is not noticeable is not remarkable then we do not feel it though they exist like if you talk in the general common sense if you talk about mathematics, you can say, I have 50 rupees. Yes? If we subtract 50 rupees by 60 rupees, what will be the answer? The answer will be minus 10 rupees. In maths, the value exists, minus 10 rupees, but in practical life, there is no minus 10 rupees in your pocket. It cannot be that, you cannot say that, I have minus 10 rupees. The value exists, that is applicable for certain sort of tasks only. Yes, in the similar things happens here. Though there is force, but it doesn't mean that the things will be bound together with the similar force. When the things will be bound together, it will be bound together only if the value of force is appreciable, is remarkable, is noticeable. You can see this, the mass of the sun, the mass of sun alone is so huge that sum total of the mass, sum total of the masses of all heavenly bodies in our solar system is just 0.001/5 to that of the mass of sun. This tells you clearly that why do every heavenly body revolve around the sun. The total mass of the entire solar system, including it means all planets, satellites in the solar system, is only 0.001/5 of that of the mass of the entire sun. So it is very huge. Its mass is so appreciable, so huge that it binds all the planets. Now we will be going to the Newton's law. This Newton's law of gravitation details that the force of attraction between any two bodies is one directly proportional to the product of their masses. One. Next he tells that is indirectly proportional to the square of the distance between them. Again, Newton's law of gravitation tells us that the force of attraction between any two bodies is directly proportional to the product of their masses. दुईटा वस्तु छ भने पछाडीबाट त्यो दुईटा बीचको फोर्स केमा डिपेन्ड हुन्छ? It tells that it is directly proportional to the product of their masses. That means त्यो दुईटैको मासलाई हामीले मल्टिप्लाई गर्ने भने त्योसँग फोर्स के हुन्छ? डाइरेक्टली प्रोपोर्शनल हुन्छ. Means mass बढ्यो भने फोर्स बढ्छ. Next he tells in another statement is that that means another part of this law is that this force of attraction between the two will be indirectly proportional. Indirectly proportional to meaning general common sense में के हुन्छ? Indirectly proportional means one side increases, the other side will decrease. That is indirectly proportional to the square of the distance between them. तिनीहरु दुईटाको बीचमा जुन दूरी हुन्छ त्यो दूरीको डिस्टेन्सलाई स्क्वायर गर्यो भने त्योसँग फोर्स के हुन्छ इन्डाइरेक्टली प्रोपोर्शनल भन्नुको मतलब डिस्टेन्स इन्क्रिज भयो भने फोर्स घट्छ यस वी विल मेक दिस मोर क्लियर by proving or by deriving a general equation that we say Newton's law of gravitation बाट एउटा general equation general formula हामी derive गर्छौं to calculate the force of attraction. For this, let us suppose there are two bodies each of masses m1 and m2 यो दुईटा वस्तु भयो एउटाको मास m1 अर्कोको मास m2 छ र यो दुईटाको दूरी द डिस्टेन्स बिट्विन देम इज यो m1 र m2 को दूरी कति छ लेट इट बी d डिस्टेन्स यिनीहरु कति छ d यु क्यान सी इट क्लियरली दैट मैले डिस्टेन्स लाई यो त्रिज्याको सर्कलको बाहिरबाट लिएको छैन आई हैव नॉट क्याल्कुलेटेड लाइक दिस यस दिस इज द रिजन इज always the distance between any two bodies is calculated from the center of one body to the center of another body. So this is the distance we have taken it from the center of m1 to the center of m2. Now what will be the force? यो हामीले के भनेको थियौ Newton's law of gravitation मा सुरुमै कुनै दुईटा वस्तुले एकले अर्कोलाई तानिरहेको हुन्छ. So यो वस्तुले यसलाई र यो वस्तुले यसलाई कतिले तानिरहेको छ? That we need. Let it be F. m1 र m2 ले एक अर्कालाई कति फोर्सले तान्दै छ दैट इज व्हाट वी से ग्रेभिटेशन द न्यूटन्स लॉ अफ ग्रेभिटेशन मा त्यही फोर्स को म्याग्निट्युड भ्यालु कति हुन्छ त्यो निकाल्न सक्छौं हामी सो व्हाट इज द भ्यालु of this force of gravitation? So first is what we have done is we will write it up here. Let us suppose the two bodies of masses m1 and m2 be separated with distance small d. Then what is force of attraction between the two? F से मानौ त्यसलाई मैले F माने यस मानौ त्यसलाई मैले F माने त्यो पिछको फोर्स कति हुन्छ 7 इन्च त्यसलाई मानौ मैले हो नाउ वी विल मूव टु मैले अगाडि इरेज गरिसके त्यही न्यूटन्स को दुईटा ल थियो त्यहाँ यस फोर्स इज डाइरेक्टली प्रोपोर्शनल टु प्रोडक्ट अफ देयर मासेस यस त्यही कारणले व्हाट वी क्यान राइट इज फ्रम न्यूटन्स law of gravitation Newton को law of जुन gravitation छ gravitation what we can write two things that is let it be here we can write two things Newton's law of gravitation बाट के थाहा पायो this force of gravitation F is directly proportional if directly proportional को sign भयो is directly proportional to the product of masses m1 into m2 let it be equation 1. Another it tells that this force of attraction is indirectly proportional to square of the distance between them. Distance के छ d छ. d को स्क्वायर को इन्भर्सली प्रोपोर्शनल छ. इन्भर्स प्रोपोर्शनल दिनको लागि के गर्छौं हामी? We will write 1 upon d square. Okay ना? This will be your equation 2. Newton's law of gravitation ले के भनेको थियो? Force of attraction is directly proportional to the product of their masses. The m1 into m2 हो force. त्यस्तै न्यूटन्स ल ले फेरि अर्को के पनि भनेको थियो इज इनडाइरेक्टली प्रोपोर्शनल भन्नुको मतलब टु द स्क्वायर अफ द डिस्टेन्स d थियो डिस्टेन्स को स्क्वायर भनेको d स्क्वायर 1 अपन किन लियौ 1 अपन implies that it is indirectly proportional getting it now if we combine these two combining equation 1 and 2 हामी इक्वेसन 1 र 2 लाई कम्बाइन गर्यो भने के हुन्छ f proportional to we can write m1 into m2 upon d square isn't it yes again I will be rubbing this portion to make me a space to illustrate you yes so from here we will go back here again f directly proportional to m1 into m2 by d square now whenever we have to change any proportionality sign into equation, that means equal to को साइन मा चेन्ज गर्नु पर्यो प्रोपोर्शनल लाई भन्ने, we always, that means the scientists always search for a constant. Yes, एउटा constant को खोजी गर्छ र यो इक्वेसन को constant के हो? g हो. Therefore f equals to g m1 m2 upon d square भएको हो. Where your g के हो? G has come to replace this proportionality into equals to. यो कसरी आउँछ? It comes as a result of different experiments. धेरै एक्सपेरिमेन्ट्स गरिसके पछाडिबाट कुन एउटा कन्स्ट्यान्ट थाहा हुन्छ. सबै एक्सपेरिमेन्टमा एउटै चीज कमन आयो भने त्यो कन्स्ट्यान्ट भइहाल्छ. So through different experiments it is found what is g. So यहाँ g के हो? एउटा कन्स्ट्यान्ट हो जसलाई where g is a proportional constant. g के हो? एउटा proportionality constant हो जसलाई एउटा छुट्टै नाउँ पनि दियो, known as universal gravitational constant. Gravitational constant, simply you can write UGC. Yes, यो एउटा universal gravitational constant हो भन्ने कुरा यहाँबाट हामीले बुझ्यौ. So this is your equation, this is your required equation. यो तिम्रो required equation के को लागि? Newton's law of gravitation. That means to find the value of the force of attraction between any two body. अब कुनै दुईटा वस्तु बडीको बीचमा फोर्स कतिको छ हो? वा ग्रेभिटेशनल फोर्स कतिको छ? To say gravitation, to say gravitational force is the same thing. Gravitation कतिको छ और force of attraction कतिको छ और gravitational force कतिको छ? Answer we can derive from this equation. अब there is a new term here. अब के भइदियो? यो capital G जसलाई हामी के भन्छौं? Universal gravitational constant. Simply we also speak as gravitational constant capital G. Capital G भनेर आइसक्यो. What is this? Now we will be finding the value, magnitude of G. So calculation G. Before going to this, we have the data already. जो G को data था, that is G equals to 6.67 into 10 to the power minus 11 Newton meter square upon, that is per kg square. The value of G कति निकाले साइन्टिस्टले पता लगाए? Its value is 6.67 10 to the power minus 11 Newton meter square per kg square. This is a constant, so we can always write this value of G in our solve while we are solving any numericals. कुनै numericals हामी solve गरिरहेका छौं भने त्यतिखेर यो भ्यालु हामी डाइरेक्टली पनि राख्न सक्छौं. अहिलेको क्याल्कुलेसन अफ G मा हामी खाली के पत्ता लगाउँछौं भने पछाडी what is actually the definition of G here? We simply know that it is a gravitational constant, but as it has a unit, it also be something. यो के हुनु? एउटा be something means it also be a physical quantity. यो एउटा physical quantity हुनु पर्छ. त यो physical quantity केसँग रिलेटेड छ? Like physical quantity we say mass. The mass is a physical quantity, kg त्यसको युनिट छ. Whenever we say physical quantity weight, the physical quantity हो त्यो भनेपछि त्यसको एउटा युनिट हुन्छ, that is Newton. Similarly, is this also a physical quantity or not? Yes, it is also. So what can it be related with? यसलाई केसँग रिलेट गर्न सकिन्छ? यसको लागि हामी केमा जान्छौं भने यसकै फर्मुलामा जान्छौं. न्यूटन्स लॉ अफ ग्रेभिटेशन बाट जुन फर्मुला निस्कियो त्यहाँबाट जान्छौं हामी. The formula it was, see here, F is equal to G m1 m2 upon d square छ भनेपछि we can also write it as this. यो G लाई माथि राखेर यसलाई यससँग मल्टिप्लाई गर्दा यो तल आउँछ. That is G will be equals to F into d square upon m1 into m2. Yes, G को तो फर्मुला पनि बन्यो यहाँबाट. यहाँ के लेख्यो? G equals to force into distance square upon m1 into m2, दुईटा masses को multiplication. So if मानौ if distance is 1 meter, जब distance 1 meter हुन्छ and m1 is equal to 1 kg is equal to m2. मानौ दुईटा वस्तुको मास पनि 1 kg छ. यस, then write it as G equals to F into 1 co square, that is we have written distance equal to 1 meter, so 1 co square, M is equal to 1 kg ko 1, arko M pani 1 kg ko 1, or it will be G equals to F. Yes, from this data we have G is equal to F, but it is not always G is equal to F. Here we do not take it in otherwise F force of attraction and G is same bhanera jaile pani lina mildaina in this condition only. If distance is 1 meter and the masses are 1 kg, in that condition G and F are equal, and we know that what is F? F is a gravitational force. It is the force of attraction between two bodies. So from this data we can from this data what we can do is we can define G. We can define G. हामी के गर्न सक्छौं? अब क्यापिटल G को डेफिनेसन दिन सक्छौं यो डेटाबाट. कसरी डेफिनेसन बन्छ? I have rubbed it here, but you can recall it. If distance is 1 meter and the masses are 1 kg each, then gravitational constant G is equal to force of attraction. This is the definition. So UGC, I have written it short form, universal gravitational constant. UGC, that is G is equal to the force of attraction between two bodies of unit mass. Unit भन्नाले 1 भन्न खोजेको हो, means unit mass भन्नुको मतलब 1 kg. G is equal to the force of attraction between two bodies of unit mass separated with unit distance. That means unit भन्नाले 1, so distance means 1 meter. If two bodies of unit mass and unit distance is there, then the gravitational constant is equal to the gravitational force. So from here what we have found the definition of G. Now we will find the unit. Though we have written here हामी अगाडि लेखिसक्यौ unit यो छ, तर how does it come? यो unit कसरी आयो होला? न्यूटन मिटर स्क्वायर पर केजी स्क्वायर. यस, एसएलसी एक्जामहरुमा एसई एक्जामहरुमा यही युनिट मात्र डिराइभ गर्न सोधेको हुन सक्छ. Simply you have to give the SI unit of universal gravitational constant. If you can write simply Newton meter square per kg square, that will deliver you 0.5 marks. Yes, र कहिलेकाहीँ they will ask you to derive this unit. यो unit लाई नि derive गर भनेको हुँदाखेरिबाट हामीले derive गर्नुपर्ने हुन्छ. त्यतिखेर the weightage of that question will be about 1 marks. So let us derive this unit. What we will do now is we will derive the unit. It is also simple one. Derive unit of capital G. Again we will move to this formula. We know F equals to G m1 into m2 upon d square. From Newton's law of gravitation. From Newton's law of gravitation. Newton's law of gravitation bata हामीले यो थाहा छ हामीलाई. Yes. So from here what we can do is or F into d square cross multiplication is equal to G m1 m2 or G equals to F into d square upon m1 m2. Yes, m1 m2. Now unit of G will correspond to unit of F into d square upon m1 into m2. Isn't it? Oh, यसको जे युनिट होला त्यही नै यही युनिट हुन सक्छ or equals to F को युनिट के छ न्यूटन. F is force, so it's Newton. Another is distance को स्क्वायर. Distance को SI युनिट के छ मीटर. मीटर को स्क्वायर मीटर स्क्वायर. त्यसपछाडिबाट m1 को युनिट m भने m1 भनेको के हो मास को युनिट के हुन्छ kg यस kg अर्को पनि के छ m2 इज अल्सो मास त मास को यसको युनिट के हुन्छ kg दुईटै kg इक्वल्स टु के हुने भयो न्यूटन इन्टु मिटर स्क्वायर kg र kg मल्टिप्लाई गर्दै भने के हुन्छ kg को स्क्वायर लाइक a into a is equal to a square so the bases are same we will add the powers kg को पावर 1 kg को पावर 1 भनेको kg को पावर 2 भएको therefore unit of capital G equals to what न्यूटन मिटर स्क्वायर यो kg स्क्वायर अपन लेखेकोलाई हामी माथि लेख्नु पर्यो भने के गर्छौं kg को पावर -2 लेखिदिन्छु यस we know this हो अपनलाई माथि लेख्नु पर्यो भने पछाडीबाट मल्टिप्लिकेसन साइन गरेर माथि गर्नु पर्यो भने पावर के हुन्छ माइनस हुन्छ सो न्यूटन मिटर स्क्वायर पर केजी स्क्वायर यु क्यान राइट लाइक दिस अल्सो यु क्यान राइट लाइक दिस अल्सो न्यूटन मिटर स्क्वायर अपन यसरी दिएर बट व्हाइल वी स्पेल जब हामी बोल्छौं त्यसलाई यसलाई र यसलाई पढ्दा एउटै पर्छ न्यूटन मिटर स्क्वायर पर केजी स्क्वायर यसलाई पनि के गर्छौं न्यूटन मिटर स्क्वायर पर केजी स्क्वायर यस सो दिस वाज अबाउट द definition of G also and the SI unit of G. Now we will read something in context with this formula. अब यो फर्मुला सँग रिलेटेड हामीले एउटा दुईटा प्रब्लम सल्भ गरेर हेर्छौं. Yes, we will be solving two problems in context with this. So let me have one question from the book. Let me have one small question from your book to solve it. Two bodies with masses of 200 kg are kept at a distance of 2 meters. Yes? Let a question be if two bodies are kept at a distance of 2 meter and masses of both be 200 kg each. Yes? Then we have to calculate the force of attraction between the two. Yes, के भनेको छ प्रश्नले if two bodies are kept at a distance of 2 meter दुईटा वस्तु एउटा वस्तु अर्को वस्तु छ यो यस त्यो दुईटा वस्तुलाई डिस्टेन्स कति पर राखिएको छ दिस इज 2 मिटर पर छ masses of both be 200 kg each भन्नुको दुईटैको मास सेम राखिदिएको छ हामी जस्तै भन्छौं m1 इक्वल्स टु यहाँ कति भयो 200 kg अर्को वस्तु m2 मान्छौं हामी त्यसको पनि मास दिइसकेको छ यहाँ कति 200 kg अब हामीलाई निकाल्ने के भन्यो व्हाट इज द फोर्स अफ एट्र्याक्सन यो दुईटैको फोर्स कति छ यस दिस इज व्हाट वी सल्भ यस इन फिजिक्स हामी साइन्स को यो फिजिक्स पोर्सनमा जहिले पनि कुनै न्यूमेरिकल सल्भ गर्नु पर्यो भने पछाडी डु योर बेस्ट इन दिस राइट कर्नर मेक द इलस्ट्रेटिभ डायग्राम यो क्वेशन के भनेको छ त्यसको एउटा इलस्ट्रेटिभ डायग्राम बनाउनु पर्छ यस इन दिस राइट कर्नर यो राइट कर्नरमा यसरी इलस्ट्रेटिभ डायग्राम बनाउँदाखेरिबाट इट विल डेलिभर यु बेटर मार्क्स it will enhance your understanding also तिम्रो understanding पनि क्लियर छ भनेर बुझिन्छ now the same thing we will write here as given conditions यो दिएको चीजलाई हामी लेख्छौं सो फर्स्टमा के भन्छौं सल्युसन शॉर्ट फर्म यस and what are given here यहाँ दिएको के छ त्यो हामी डेटा सहित तर त्यसको सिम्बल के युज गर्छौं हामी न्यूमेरिकल सल्भ गर्नको लागि त्यो सहित हामी यहाँ लेख्छौं अब हो त के दिएको छ फर्स्टमा दुईटै मास दिइरहेको छौं मानौ त मास of a body के symbol m1 कति छ 200 kg isn't it next is mass of अर्को body other body दुईटा body छ यहाँ त्यसलाई हामी symbol के युज गर्छौं m2 अर्को वस्तुलाई m2 त्यसको मास पनि सेम भनिदिसकेको छ यहाँ 200 kg m2 is also 200 there we have given the separation that is the distance between them we will write the same thing in the short form distance between them symbol के use हुन्छ small d is given out here 2 meter yes now what is asked calculate the force of gravitation okay na the force of attraction फोर्स अफ एट्र्याक्सन को सिम्बल के हुन्छ क्यापिटल एफ हो किन हामी इक्वेसनमा पनि दिइरहेका थियौ इज इक्वल टु वाट भनेको छ अगेन हामी जहिले पनि प्रब्लम सल्भ गर्दाखेरिबाट वी विल मुभ टु द इक्वेसन हामी इक्वेसनमा जानुपर्छ हामीले पढेको इक्वेसन के थियो भनेपछि मैले सिम्पली यहाँ लेखे f इज इक्वल टु gm1 m2 अपॉन d स्क्वायर जुन लेख्छौ यहाँ तिमीलाई f निकाल्न भनेको छ m1 दिएको छ m2 दिएको छ d दिएको छ हो इफ you don't have this capital G तिमीलाई capital G को भ्यालु थाहा छैन भने you cannot calculate this f हो किन किनकि दुईटै भेरिएबल भयो भने त आन्सर त आउँदैन यस so we should know this G थाहा हुनुपर्छ र अगाडिकै हामीले पढाउने बेलामा के भनेको थियौ universal gravitational constant G is a constant भन्नुको मतलब त्यसको भ्यालु फिक्स्ड हुन्छ र त्यसको भ्यालुलाई हामी डाइरेक्टली लेख्न सक्छौ दिएको छैन देन अल्सो वी क्यान राइट इट गिवन मै लेख्न सकिन्छ सो हामीलाई के थाहा छ वी नो हामीलाई थाहा भएपछि डाइरेक्ट लेख्न मिल्यो वी नो व्हाट gravitational constant what is capital G equals to we know this data के होत्यो this is 6.67 10 to the power minus 11 Newton meter square per kg square isn't it यो भ्यालु हामीलाई थाहा भएको डेटा हो यस युनिभर्सल कन्स्ट्यान्ट भएको कारणले हामी डाइरेक्टली यो भ्यालु लेख्न सक्छौं now we will be solving the equation we will be using the formula use गर्नको लागि you can simply write what from Newton's law of gravitation Newton's law of gravitation what we have same F equals to G m1 m2 upon d square this is the equation given from Newton's law of gravitation now we will simply put the values magnitudes and then find the answer so again or F equals to G को value कति छ 6.67 10 to the power minus 11 yes we will not use the units हामी unit न use गरिकन गर्छौं यहाँ finally we will write the directly unit into m1 कति 20 अर्को m2 कति 20 isn't it 20 or 200 sorry 200 it is 200 now distance what is the distance 2 meter yes so 2 but the formula is distance to square so what we will write 2 go square is that say mass m1 200 kg mass m2 200 kg distance d 2 yes but formula has square so 2 go square before solving this yes we will follow some guidelines though we can use the scientific calculator here yes यो possible पनि हुँदैन scientific calculator बिनाको power of 10 को but then also we will solve it in certain steps यसलाई हामी अलिकति स्टेपमा सल्भ गर्छौं what we will do is we will make ease हामी अलिकति सहजता बनाउँछौं नम्बर्स को एउटा मल्टिप्लिकेसन गर्छौं र powers of 10 को सँगै राखेर मल्टिप्लाई गर्छौं like see it or f equals to 6.67 यही छ into 10 to the power minus 11 अब 200 भन्नुको मतलब के लेख्न सकिन्छ यसलाई 2 into 10 को power 2 into 2 into 10 को power 2 do you get me 10 को power 2 means 100 2 is 200 yes 2 into 100 200 yes तल 4 yes we will move little up here let us have to write it again I will erase it to this yes I will rearrange these data though you can calculate it directly from your calculator also from here let me be here again or what I am doing is मैले यहाँ के गर्दै छु त्यो हेर्दै जाने f डेटा लाई मैले नम्बर सँगै राख्छु 6.67 into 2 into 2 into 10 को पावर minus 7 minus 11 into 10 को पावर 2 into 10 को पावर 2 do you get me मैले के गरे 6.67 यो 2 र यो 2 सबै मल्टिप्लिकेसन मा छ मैले रिअरेन्ज गर्दिए नम्बरलाई एक साइडमा अब पावर अफ 10 मा सरी यहाँ 10 to the power minus 7 हैन 10 to the power minus 11 this 10 to the power minus 11 यहाँ आयो यस 10 को पावर 2 10 को पावर 2 नेक्स्ट 10 को पावर 2 यहाँ आइसक्यो यस अपॉन छ त्यहाँ 2 को स्क्वायर इज 4 आउट देयर this is clear yes एकछिन हामी क्लियर छौ now you can use your calculators to get a divisible number from this 6.67 to the 2 and like this. But it is very easy here. 2 1s are 2, 2 2s are 4. 2 1s are 2, 2 2s are 4. 2 1s are 2, 2 1s are 2. Sorry, 2 1s are 2. 2 1s are 2, 2 2s are 4. Now 2 1s are 2, 2 1s are 2. So this 4 you cancel this. Okay, mind you, F equals to 6.67 into your 1 10 to the power minus 11 above. If the bases are same, 10 to power you can 10, you can 10, you can 10. Yes, like you can simply say a square into aq into a को power minus 4. त हामीले like सर्ट्स मा पढ्दाखेरि म्याथ्स मा कसरी गर्थ्यौ यसलाई? यसरी लेखेको छ भने इक्वल्स टु a को power 2 plus 3 minus 4 equals to a को power 2 plus 3 भनेको 5 minus 4 equals to a to the power 1 equals to a हुन्थ्यो आन्सर. Yes, similar is the condition out here. 10 bases are same, powers should be added with their sign convention too. Your sign convention सहित added हुन्छ. तो 10 को power minus 11 यो 2 को मतलब plus 2 यो 2 को मतलब plus 2. Yes, or f equals to 6.67 into 10 to the power 11 minus 4 is equal to minus 7. Now this is force, and we all know that the unit of SI unit of force is simply Newton, so we can write directly here Newton. So finally, what is the answer? The force of attraction is, therefore we will write here in sentence. Our sentence ma lekh dinchau. Therefore the force of attraction between the above two masses, यो माथि दिएको जुन क्वेशनमा भएको मासेज छ त्यसको between above two masses is 6.67 into 10 to the power minus 7 Newton. This is your answer. यो तिम्रो आन्सर हो. यसरी ANS लेखिदिन्छौ हामी, आन्सर हो. अब यहाँबाट हामीलाई अर्को चीज के चाहिँ बुझाउनु छ भनेपछि यो आन्सर त भयो, but see the value. यो भ्यालु कस्तो होला? 6.67 10 को पावर minus 7 भन्नुको मतलब 0.6 वटा 0. Yes, it is something like this. 0.6 वटा 067 Newton. This is nothing actually. यो प्र्याक्टिकल मा अगाडि मैले कुरा गर्दै थिएँ, I have minus 10 rupees, I have minus 200 rupees भने जस्तै. What is this? This is nothing in practical. So यो दुईटा 200 kg मास भएको फोर्स अफ एट्र्याक्सन त भ्यालु त आउँछ, बट इन प्र्याक्टिस we cannot see. यो दुईटाले एकअर्कालाई तानेको र अगाडि बढेको हामी देख्न सक्दैनौं, तानिँदैन यो. यस, यहाँबाट के प्रुभ भयो भने पछाडी फोर्स अफ एट्र्याक्सन त रहन्छ, तर त्यो रिमार्केबल छ कि छैन त्यो हुनुपर्छ. त्यसको लागि के हुनुपर्छ? एउटा बडी एटलिस्ट शुड बी ह्युज, धेरै ठुलो छ भने पछाडी त्यो फोर्स फिल हुन्छ. फर एक्जाम्पल लिन सक्छौ, यो मार्कर तल गयो, किन गएको छ? बिकज देयर इज द फोर्स अफ एट्र्याक्सन बिट्विन दिस मार्कर एन्ड द अर्थ. यो टेबल होइन, यहाँ टेबलले यसलाई तानेर ल्याएको होइन, यो यसलाई छोड्यो भने यो भुइँमा पनि जान्छ. गेट मी? So Earth is huge. Its mass is 6 into 10 to the power 24 kg. Oh, the huge mass ले force of attraction मा हामीले भ्यालु हाल्यो भने निकाल्यो भनेपछि you will get a significant amount. त्यो noticeable amount पाउँछौ. 5 Newton, 2 Newton, 200 Newton, 2000 Newton यसरी भ्यालु आउँछ. र त्यो फोर्स को मिनिङ हुन्छ. So for today, this will be the end of today's chapter. We will be reading our remaining section. What is out there? Gravity, acceleration due to gravity, variation of the earth, variation of G on the earth, free fall weightlessness, and we will discuss also about mass and weight in our next class. Thank you.